Yes, so far we have seen uh, first unit, we have seen the general introduction of how the unit is going to be, how your portion is going to be. Then from second unit onwards, we started with our regular expressions. Then we saw what is DFA. Okay, so I hope you remember what is DFA so far. Okay, so DFA. Okay, so if next is about NFA. So if and only if you understand the concept of DFA better, then you can go to NFA. Okay, so before going to NFA, we'll see once again what is DFA is. So DFA is deterministic finite automata. So by the word deterministic. Okay. So by the word, you will know that you're defined. Your it is something is predefined. Okay. So you have this DFA is defined by Q epsilon, sorry, sigma, del, Q naught and F. Okay, I hope you are remembered. You have remembered this. Okay, so these are the representation. Through these five tuples, we will be generally defining DFA. Okay, so based so then we saw how to convert by using these tuples. So Q always represents the number of states. So it says what are the states you have there. It's there um, in your DFS. Okay, so it represents number of, okay, set of states. Okay, it's not number of states, it is set. Okay, it is always defined in set of states. Then this sigma represents what are the set of inputs. Okay, inputs. Then del represents your transition function. Okay, this del is usually represented as Q cross sigma gives Q, which means on some state, if you're applying some input. So Q represents states and sigma represents inputs. So on Q, if you're having some input, if you're putting some input on some state in any one of the state among the set of states, you'll have another state. You'll transit to another state. So that is what del represents. So on applying some input on a state, it transmits to your another state. Okay, that is what del is. So del is represented by Q cross gives Q. Okay, so this is what your del is about. Okay, transition function. Okay, next is Q naught. Q naught is your start state. Start state. Okay, the state, there will be only one start state in DFA. Okay, F will be your final or end state. Okay, since there can be any number of final states, so it will be represented in the form of set. So set of final state. Okay, so this is how the tuple is represented. Okay, so with a diagram, I'll explain how these are okay, how these are represented. Okay, so for example, A, B, sorry, fine. So, okay, so this is a random example that I'm taking. Okay, 0 and it is C. Okay, so, okay, so now, for example, 1, 0 and whatever. Okay, so in deterministic finite automata, so why it is determined, what is determined here is whatever the input may be. Okay, whatever the state may be, when on applying input on a particular state, it will be going to some other state. So the transition is predetermined. So when applying 1 on A, it will go back to A itself. On applying input 0 on A, it goes to some other state. So this is determined. So that it is called as deterministic finite automata. So from the given diagram, we can the tuples can be represented as Q is set of states. So the set of states are A, B, and C, and sigma's set of inputs, that those are zeros and one, and star del is generally you will be representing with a table of form, that is Q on input will give you another Q, that is you'll be on applying on a state. When you are applying an input function, it will transfer to another state. That is what del is. then is Q naught. Q naught is your start state. The start state is arrow coming from nowhere is represented by represented as start state. So here it is A and sorry, and F. Okay, so F is your final state. So F is your final state. So was it is represented as set. Here in this example, there is only one final state. There will be more than one final state in DFA. Okay, so this is how we represent. We can represent DFA in the form of tuples. Okay, tuples. Fine. So so if you know, if you are in one state, by applying the input on one state, we'll be knowing what state it will go. Okay, like in transition table, on applying, suppose there are three. Here there are, okay, so there are three states. So A, B, C. On A, on applying 0, it goes to B. On A, applying 1, it goes to A. So likewise, we through the transition table, we know what we are going to do, what happens if you are applying the inputs on each state. Then the transition between the states are already determined. Because of this, the transition between the states are already determined. Only one unique state from one state, it goes to the next state. That is unique. It has only one unique state. So on applying one input, it goes to only one unique state. It will not go to n number of states. So for example, here A on 1, it goes to one state called A. On 0, it goes to one state called B. It is not going randomly going to every states. Okay. So there is no randomness and there is only uniqueness. So, and it is also quite easy to construct. Okay. So now we know what is DFA is. Okay, so it has a uniqueness, but it doesn't have a randomness. It will not have a random access of other states. Okay, it has unique state. Okay, if one applied, it will go to one unique state. It will not go to n number of states. So this is about DFA. Now we'll see what is NFA is. So I'll draw the example diagram so that you'll understand the difference between NFA and DFA. Now it is NFA. So NFA is very similar to DFA, but the transitions are non-determined. Okay, determined. Here all the things are predetermined. Okay, so this is the difference between major difference between the main difference between NFA and DFA. Okay, so fine. So now I'll draw with an example. I'll tell you with an example. A. Okay, so this is what your NFA is. So you can see many difference between this DFA and NFA. Okay, so I'll draw this DFA also so that you can compare it very easily. So the same diagram I have taken. A on 0 goes to B, and on 1 on C. Fine. Okay, so this will be 1, 0, 1, 0, 1, and 0. If it is 1, it goes back here. So, okay, so these are random examples. Don't take it as the proper example. It's a random example. Okay, so this is for DFA and this is for NFA. Okay, so by seeing this, you can say that here on applying, okay, so here every states are having all the inputs. Okay, so here A has two inputs, 0 and 1, B has input 0 and 1, C has input 0 and 1, and there is a transition while applying on the each input. But here you could see there's a start state, that's the end state, that is defined, but then all the state doesn't have the inputs. Okay, so on A there should be 0 and 1. So yes, this A has on 0, it goes to A or B, and it also goes to on up 1, it goes to A. But for B, there is no transition. So NFA can be defined in this own way, in this way also. Okay, instead of going for every input and output transition, you can use only the needed one. Okay, so if the things are, you would have remembered that if you want only 0, 0 in your if the string should be, if you want to convert DFA with the strings accepting only 0, 0, then you can generally just create like this 0, 0, and whatever 0, okay, so it will go for on up first 0, it will go to state B. On second 0, it will go to state C. If suppose it has some other state called another input called 1, whatever the input may be, it will be coming back to the dead state. Okay, so this is how your DFA is implemented. But if with the same thing, if you want 0 0, your strings with 0 0 should be accepted. If you want to construct in NFA, then you can go only for the basic ideology. That is, you need only whatever the inputs you need, you can give it you in that way. Okay, so that's all. You don't have to define what happens if one comes as an input, what happens if two comes as an input. Okay, so if other state, if suppose this A state on input 0 goes to B on input 0 goes to C, but whatever the values of 1 or any other values come, you don't have to define for every state. Okay, so that is one advantage of NFA over DFA. Okay, here what for all the inputs we have said what happens for each state at each state. For 1, what happens at state 0. For 0, what happens at state A. Similarly, for B, if 1 applied, what happens? Or B, 0 applied, what happens? We have to define in DFA. But in NFA, you don't have to do it. You randomly, you can choose what are the transition you need for each state. Okay, that's all you needed. That much is enough for defining or describing or developing or designing a NFA. Okay, that is a major difference between DFA and NFA. One more thing is, here you can have the same value. For example, here on 1, it went to only one state, that is unique state. Okay, similarly on 0, it went to one unique state called B. But here on A, on applying 0, it can either go to A as well as on B. So it has two different options to traverse or to transfer from one state to another state. Okay, so this is also applied in, this can also be used in NFA. So the major difference is it can have a random access of state, random access of another state. So randomly it can go up access the next state. Next, it doesn't have uniqueness, no uniqueness. Okay, so it doesn't have uniqueness. Okay, and it can also be it can also have empty state or incomplete state. You can also say that as incomplete state. Okay, that is, the B doesn't say if 1 applied on B, what happens? If 0 applied on B, what happens? It can have an incomplete state also. Okay, so these are the major difference between DFA. DFA will have a detailed version or detailed steps for implementing or finding an answer. But here in NFA, whatever you need, what else you need, which thing is needed for the particular problem is used. The other things, the rest of the things are left. Okay, that is the difference between DFA and NFA. Okay, so we'll solve with an example. Okay, so before that we'll learn how the DFAs are defined. Okay, so fine, fine. So we'll see the definitions of NFA. So as said before, similar to DFA, NFA also have 5 tuples, that is Q, sigma, del, Q naught, and F. Okay, so these are the 5 tuples. Okay, similar to DFA, you have the same 5 tuples. This represents set of states. This represents set of inputs. This represents start state. This represents set of final state. And this represents the transition function. There in DFA, your transition function was Q on applying some input will give you to, you will transit to or transit to another state. Here it has different opinion. For example, the same example I'll take and teach you. Okay, so it is A. Okay, on 0 and 1 it goes to A, but on 0 it can also go to B. Okay, so from this what you can say is, okay, A, okay, on 0 Okay, A on applying 0, where it goes to A. Okay, similarly, A on 0, that this is input. Okay, so A on input 0, it goes to A. Similarly, A on input 0, it can also go to B. Okay, next, A on input 1, it goes to A. Yes, so it is self loop, so it goes to A. Similarly, B doesn't have any input, so you can represent that as null. Okay, goes to null. Similarly, B on sorry, this is not null. 1 minute. So similarly, B on 1, it goes to, there is no transition is shown here. So you can say it as null. And similarly, B on 0 goes to null because there is no transition for 0, input 0 as well as input 1. So you are telling that it doesn't show. So you can represent by null symbol. Okay. When you look into it, you can see that A on input, okay, A on some input, okay, where it goes to A, it can go to A, B, okay, or AB together, or sometime it can also go to, from this diagram, what we can see is, suppose if A is a given state, on input on A, it goes to A, or if there are two states called A and B. So on A, if some input is applied, it can either go to A itself, or it can also go to B, or it can also go to A and B, or sometimes can, like B scenario, it can also go to null state. Similarly, so from this, okay, similarly, if there are three states A, B, C, okay, okay, the same scenario, think in that way. Okay, A on applying some input, where else it, where, what are the places it can go? It can go to A, or it can go to B, or it can go to C, or it can go to AB, AC, BC, and also it can go to A, B, C. All three states it can go, and and also it can go to some null state also. So if there are two states, how many transition can happen? 1, 2, 3, 4. Okay, that is 2 power 2. Similarly, if there are three states, how many transition? How many transition can happen? This is can happen. It is not happening. It is can happen. 1, 2, 3, 4, 5, 6, 7, 8. So 2 power 3. So from this, what you can say is, okay, so the Q will be represented as, okay, so Q, not Q, the del can be represented as Q into on Q, that is on state. When you're applying some input, where are the places it can go? It can go to 2 power Q states. Okay, the transition can happen at 2 power Q states. So the del is Q cross summation is gives 2 power Q. Okay, so there in DFA, it went to only one state. Okay, so we have represented as Q, but here NFA, it can have any number of access. It has random access to another state, so it is represented as 2 power Q. Okay, so these are the major difference. This is the major difference between DFA and NFA. Okay, so we'll see with some examples so that you can understand this very clearly. Okay, so I hope you are listening the class and you are getting what I'm trying to teach. Okay, it is similar to DFA, and there is no major difference between DFA and NFA. Since the thing is, if you learn NFA first, it will be difficult for you to construct DFA. But if you have already learned DFA, so it is very easy for you to construct NFA, because you are just cutting some transitions, and you are just keeping only the necessary transition in your diagram. So that gives you NFA. You have detailed explanation of your diagram or how the actually the flow works. That will be your DFA, and cutting the unnecessary things and having only the necessary flow, that gives you NFA. Okay, so that is the major difference. So you have learned, okay, the NFA part, okay, DFA part, so that it will be easy for you to develop NFA. The same thing, whatever we did in DFA will be repeated in NFA with limited number of steps. That's all. Okay, so we'll solve with an example. So first example is L is the language. Language will be accepting set of all strings that ends with 0. So for this language, we are going to construct NFA. So what does that mean? We are going to, okay, set off all strings that end with 0. Okay, so what we'll do in DFA? So, okay, so this language is given along with the diagram of how it happens. Okay, so the diagram is given already in the question, so which will make you to understand it very clearly. The same thing, the same example. So this diagram says that it's a language that accepts, or this machine will accept all the strings that ends with 0. Okay, so here, because this is 0, one transition is happening, and when the 0 occurred, that comes to the end state. Okay, so this is your, through the double circle you can represent the final state. Okay, so I hope you are remembering this. Okay, fine. So this is what your this question is about. Okay, so now we are going to check whether it accepts, this NFA accepts the string that ends with 0. Okay, so for example, what are the strings this language will be accepting? 1 0 0 0, or 0 alone, 0 0 1 0, then 1 1 0. So any kind of string that ends with zeros are accepted by this particular language. Okay, so we'll check whether it is accepting or not. So we'll take some random example like 100. Okay, first I'm taking 100. This string 100 is taken, and I'm applying on this machine and checking whether this is accepted in this machine or not. Okay, so on A, so what happens? The first string is 1. So on A, on A, when 1 is applied, what happens? There is only one transition, that is, it comes to A. Okay. Similarly, next is 0. So on A, when we apply 0, it goes to A as well as it goes to B. So how I'll represent? So I can represent in this way. So on A, when 0 is applied, either it goes to state A or also goes to state B. That is acceptance states. Okay. So there are two transitions. Then on 0. So among these two states, which state has transition? Only A has some transition, because only A has some input coming inside it, but B doesn't have any transition. So we are continuing from A. So 1 is applied, 0 is applied, one more 0 is there. So on A, when 0 is applied, what happens? Again, it goes to two states, one on A on or one on B. That is your final state. Okay, so the string is ended. So we'll continue our transition now. We'll stop our transition now. Okay, so this string is accepted. Why how we can say this string is accepted? Because when you can see, this string has started from a start state, and in the among the two transition, among the two states where 0 can go, it can either go to A or it can go to B. Here at the end we are choosing it reached B, and we are telling this string is accepted. Okay, but here if, okay, so this thing is accepted because among the two transition it can choose this path, a B. Okay, so A, this A, okay, again one A and B, so I forgot. Okay, so based on this path it had taken, it can reach the transition. Okay, that string is accepted by using this machine. Similarly, I'll take one more example to make you understand clearly. Okay, one more example is second type of string is 0 1. Okay, so by seeing you can say that this string should not be accepted, because we have created this NFA is created based on the string that will accept, that the string which has 0 only will that only sorry, string which ends with 0 will only be accepted by this machine. So we'll check whether it is accepting or not. So first is 0. Okay, so where it will start with A, on applying 0, it goes to two states called either A or it goes to B. Okay. Next is 1. Okay. Since B doesn't have transition, you can continue a transition from A. So A on applying 1, where it goes to A only. It doesn't go to the final state. Okay. If suppose there is one more state, and if there is 0, you can say that it goes to B. Okay, this string will be accepted, but here the string that is given is 1, so you have to apply 1 on A, which goes to A itself. It will not reach the end string or the last string. Okay, so because the last state, so because of this, this string is rejected. Okay, so this machine is working properly by accepting the strings that ends with only 0. Okay, so this is your right machine. Okay, similarly we'll solve, I'll solve some more example. Fine. Fine. So the second example is L is equal to set of all states that starts with 0. Okay, so you should create a machine NFA which starts with 0. So the strings will be 0, 0, 1, 0, 0, 1, or 0, 0, 0, 1, etc., or 0, 1, 0, 1, something. It should start with 0. So your machine should be in construct, so it will be infinite set, but the machine should be accepting all these values. Okay, so from this, how we can construct? So from, we have one set, it just starts with 1, 0. So from state, if I get 1, 0, I can say my machine is accepted. Okay, so it suppose 0 is accepted. Okay, so if the string given is 0, this is accepted in this machine. If I give 0, 0, what happens? 1, 0 is here, another 0. For another 0, what you will do? I can go like this. So once a 0 appeared, after that, whatever the number of zeros may be, I can make a self loop and I can put it in the same inner state. Okay, fine. So 0, 0. Fine.
என்ன பண்ற பண்ணிட்டியா பண்ணிட்டே என்ன ப்ராஜெக்ட் நேம்
Fine. Next is, suppose if I have one more string called 0, 1, 0, 1. Okay. So 0 is starting from this state. Okay. It will go to next state. So I'm constructing the machine based on the idea what are the strings can be accepted by this machine. So 0, 1, 0, 1. So 0. If 1 comes, what happens? I can put it inside this itself. So 0, again 1, it will be in the end state. And again, if 0 comes, it will be in the end state. If 1 comes, again it will be in the end state. So construct the machine such a way that it is very easy to implement. Okay, think in that way and construct a machine. Okay, for another string is 0, 0, 0, 1. Okay, so let's check whether this string is accepted or not. So for 0, it comes to this state, and for another 0, it will be in the end state. Another 0, it will be in the end state. For another 1, it will be in the end state. So my machine is working properly. So let me check. So don't only check for the proper language, check for the opposite way. For example, this machine will be accepting only the state starting with 0. So now you check for the opposite. That is, suppose if the string is starting with 1, 1, 0, 0, check for the string and check for the string by using this machine. So sometimes you will find some problem when you are going in the altered way. Okay, sometimes this machine should accept only the string which starts with 0. Sometimes if your machine is not proper, your machine will be accepting the string that starts with 1 also. Okay, you can face this kind of problem in DFA. So please think about it and draw generate the machine. Okay, so now I'll check for 100. Okay, for A, there is no transition. I have not given transition and I don't need the transition, because if it is DFA, we would have created a dead state and we'll be putting every one, okay, in the dead state. But here, since it's an NFA, we need only the strings that start with 0. So I have only the strings that have starts with 0, and the inputs only that starts with 0 is given here. Whatever other input I get rather than 0 will not be considered at all. So I'm just saying it is not accepted directly. Okay, so but the same scenario, if I want to construct a DFA machine, how it will be? A, okay, B will be my end state, 0. On 0 and 0, 1, it will be there. Okay, but for A, if suppose A is on A, when I'm on state A, if I get 1, that is the first symbol, string is 1, what I'll do, I will create a dead state and I'll put the value of 1 here. So for example, if I get 1, it will be going to dead state, and whatever the values after that one will be stored in the dead state itself. It not move come from this state to the end state. Okay, so this will be my the same question. DFA will be in this way. Okay, but I don't want this kind of unnecessary things in my NFA. So I'm just saying that what are the states I needed for constructing the, what are the transition I needed, what are the states I needed for constructing the particular question alone is needed. Okay, so this is the second example for NFA. Okay, so next is we'll see only one more example and we'll wind up the session. Okay, so the third question is okay, construct NFA with accept set of string over length 2. Okay, so for length 2, so there are strings with length 2, 0, 0, 0, 1, 1, 0, and 1, 1. So these are only 4 strings that has length 2. So your it is not infinite state. You can easily create this. Okay, so if it is DFA, what you would have created A, okay, 0 and 1 go to B, and whatever values of 0 and 1 go to C, and okay, so this will give you a right answer. Okay, for example, this is your DFA. Okay, I'm comparing with the DFA every time. Okay, so for example, if this is 0, 0, on 0 it will come to B, on another 0 it will come to C. This string is accepted. If it is 0, 1, on A, on applying 0 goes to B, and on applying 1 it goes to C. This string is accepted. If it is 0, 0, 1, okay, actually this DFA should accept only the strings of length 2. Okay, more than 2 is not accepted, it should be rejected. Okay, that is, if it is 0 it comes to B, on 0 it comes to C, but it is third string is 1, so it goes to dead state. So whatever values after 0 after reaching dead state will be in the dead state itself. So now I can say that my DFA is working properly. Similar way, how the NFA is constructed. Okay, on A it goes to, on whatever values of 0 and 1 goes to state B, and whatever values of 0 and 1 goes to state C. Okay, this is what I needed. Okay, after that it comes, I don't want to know, because anyways it goes to null state. Okay, for example, if 0 is this 0 is the string, on A it goes to B. Okay, on B if you apply 0 it goes to C, it reached the final state. So your NFA is working properly. Similar way, I'll take one more example like 0, 0, 1 to check how the NFA works. Okay, A, on applying 0 goes to B, and applying 0 on B goes to C. Okay, and on applying 1 on C, it goes to null state because it doesn't have, the no transition is represented here. So I'll say it goes to null state. So it is also called as dead state here. Okay, so here dead state is represented by a state diagram, but here it is not represented in that way. Okay, so this is how NFA and DFA works for a particular problem. Okay, so whatever problem you are solving for DFA, so I'll give you idea how to understand a DFA better. Whatever problem you are solving for DFA, go finding answer for NFA also. Or if you're solving problem for NFA, go find answer for DFA also, so that you can remember how DFA and NFA can be implemented easily. Okay. Okay, I hope you are getting this class. Okay, so this is the basic idea of what is NFA is about. So NFA and DFA is not a bigger difference. They doesn't have a bigger difference. The difference only in the transition part, where DFA has single transition on single input. On for a particular state, on applying as input it goes to a single state, but on DFA it can go to any number of states. On NFA it will, but for NFA it will go to any number of states. Okay, that, and in DFA we'll be defining every path for every input very properly and detailed way, but in NFA we don't have to do the unnecessary things. Whatever is needed, whatever the question is given, you can create the NFA only for the particular thing alone. Then unnecessary transactions after that can be cut down. Okay, so these are the major difference between NFA and DFA. I hope you understood today's class.